is Bernhard with the presentation about open source software which you could use for your IoT solution. And then Marcel Hečko will tell us something about his own IoT project. So I will now let the speaker speak.
Okay, thank you very much. Okay, great. Hello, my name is Bernie. I'm working at guhIO. We're kind of IoT service provider. We have made an IoT agent, an open source operating system, more or less. And I will today present you how to use our software connected to a cloud, how to make your own RF devices with 6 low-power nodes, and show you how to use our user interfaces. You can customize the user interfaces, and at the end I will show you how some example implementations and what we are doing. Okay, yeah, this is more or less what we're doing. We make a stupid thing smart. Yeah, smart. We connect it to the internet and to an app. This is the software architecture from guhIO. It runs on top from Ubuntu Core. It's a new IoT operating system. And we need at least ARM Hive architecture. So Raspberry Pi would fit perfect. So what does the core? The main software that is running on the IoT agent is core. It has a log engine, a database for the events. It has a rule engine, so you can make some things more automatically. For example, the door is open, switch off the heater. But it's not only restricted to smart home applications here, it's for all IoT. Here we have a device manager that can dynamically load new plugins. You can install plugins during runtime, so it's not limited to the devices. You can extend the devices every time. And we have several server interfaces: a REST API, JSON RPC, and WebSockets. Also, the mobile apps, the command line interface, and the web interface are open source and available at GitHub. So this is, how does it work? guhIO is running on the edge router. Let's get connected to the Wi-Fi router, and the mobile devices, if they are in the local area network, they connect through the router to the edge router. If the local area network is not available, they will connect to the cloud, so to the private server infrastructure. Yeah, here you can see where you can get the whole software at GitHub/guhIO. Yeah, the whole software stack is the agent guhIO. On top, we use the private software servers. Basically, the raw and context broker. This is a publish-subscribe server. It's IoT agent subscribes at the server, and the mobile devices can then connect via WebSockets to the router to the edge router. So you can access the guhIO edge router from everywhere in the world. The IF node, like this one, programmed with Contiki OS. Maybe you know it. Yep, know it. And the interface is running on the mobile apps. What is Fiware? Fiware is an open source project from the European Union. The EU has spent about 100 million euros for this software package, and it's available for free. It's GPL license, I guess. And it has now its own accelerator program, also in Bratislava. So they finance the startups to use the software. That's why I'm here in Bratislava, because tomorrow at the Spot Accelerator in Bratislava, they will select some startups who use the Fiware software and finance them.
Who's developing this? Who is the main developer of Fiware?
The most developers are in Spain, but they are all distributed in whole Europe. Also here in Bratislava, there are some developers.
So it's developed by community.
Yeah. Financed by the European Union.
Yeah, I see.
And what is it
Yeah,
exactly?
they give you money, they give you the support for the implementation, and they also provide some servers. So if you have an application, they host also it on their servers. These are Fiware it's a software package. You can use it for FiTech startups. You can use it for IoT. There are a lot of different applications. And the software packages I use for the IoT is the ORM context broker, the public subscribe server. Cygnus and Cosmos are big data software that takes the data from the context broker and stores it in the MongoDB database. And the PEP proxy and Keystone are two parts for the authentication. It's mostly used in OAuth to applications. Yeah, you can see here. It's also available at GitHub. It's mainly programmed by the Spanish company Telefónica. Do you have some questions for the Fiware program?
What is the main purpose of the library or the software package? Or
the main purpose is they want an open source alternative for the Amazon cloud, for example. They want the European startups less depend on the American companies.
Right, but it's a networking library, or is it a software component, or just it's just the framework, right? For the communicating with the devices or with the cloud, or
yeah, that's the package from Fiware has a lot of applications. It's
something like messaging framework.
Yeah, you know the Amazon cloud.
Yeah.
Yeah, you can use it just as for a virtual host server, but they have also this kind of software packages to install it. It's more or less the same principle behind.
Okay.
They offer you the server, and you can install the additional software packages. And it's not only for the IoT. Right. They have also
Can you go back one slide, please? Can you give us an example for every single piece of those things? Like, what is the example for Orient Contiki Fiware and like the example application?
The Orient context broker is mainly used like a pipe. You have an input from data and pipe it, for example, to the Cygnus to store it into a database.
So Cygnus is
more an interface for a database. Yeah.
Okay.
Yes, Cygnus is mainly used for big data applications. You can search for historical data and make some statistics for. The context broker, I will use it. We use it for the remote control. So we have the WebSockets. WebSockets connect from the IoT agent to the cloud, from the cloud to the mobile phone. But we use it also for the help desk access. So the help desk has the help desk interface and get the error log from the last days from the customer. So if the customer calls, the help desk knows what's going on and tells him what he should do to solve the problem. And the PEP proxy and Keystone are two parts for the authentication. You can use the software. Keystone is the user database where all the tokens are stored, and PEP proxy is just the remote authentication for this Orion context program.
What protocol is used for the authentication? OAuth 2.
Mainly, we use only OAuth 2, but I guess there are also other possibilities. It's not restricted to that one. So you can run the keystone on a complete different server than you run the Orion context protocol, because the PEP proxy will check from the other server if the user is allowed to access the data. Yeah, I have no other examples which startups are currently using the software. But
Okay, cool.
take a look.
After tomorrow, we will have some more.
Yeah, you can take a look at the homepage. It's fiware.org. Some of you already know the Contiki operating system. It's also an open source operating system. It's mainly used for radio devices. You can see the notes here. We use a Atmega 128. You can program it with Arduino. There's an Arduino library for that device. And this is the so-called Werko board. Maybe you have already attended the IoT meetup in Vienna. The guys who are making this IoT meetup, they are producing this developer board. Contiki OS is based on, and this node is based on the IEEE 802.15.04, more or less 6 low pan, 2.4 gigahertz, so you can use it everywhere around the world. And maybe you recognize the software stack is the same like Thread is. If you heard of Thread before, it's an upcoming IoT wireless standard developed by Google. And we use Core and IPSO for the application layer. Core is a RESTful service, so it's the protocol is almost the same like HTTP is. It's all based on ETF standards. I can show you later how it's implemented in guhIO. So now we have the devices included. As devices get automatically discovered by guhIO. So if they are near the device, they will appear in the API and in the interfaces. And if you have a connection to the server, it gets automatically uploaded to the cloud server. So these are our current interfaces. They're all open source. We have the web. The guhIO has a built-in web server. We have mobile apps for Android and iOS. And we have a command line interface for development purposes. With the command line interfaces, you can see the error logs, you can see the devices, and yeah, mostly used for debugging. There's into the apps, there's a simple web interface. There's just one file you have to where you can customize the whole. Where you can change the colors and upload your own logo, so you can customize it for your company's needs. This is how the apps are built on. We use the Ionic framework. So we program it once and deploy it for every app store. We're using the web technologies like AngularJS. We use mostly the framework from the soft parts from the web interface, including into the Ionic framework, and yeah, that's mostly how once you customize the web interface, it's also the apps then customized. So you have once to work and deploy it everywhere. The mobile apps is also available at our GitHub website, /go mobile app. But this is a simple implementation of our software. It's a bar where you have these call buttons on every table, where you can call the waiter. The waiter has a smartphone where you can see the next table who had ordered. He sees if the beer is ready, for example, and yeah.
What is the smart light for?
The smart light?
Yeah.
The bulb?
There are call buttons, smart light.
Yeah, in this application, we use a bulb where as indicator the beer is ready to be taken for the waiter. So it knows how to get to the bar.
The indicator.
Yeah. This is what we are doing as a company. We're offering all the software for free, but if you need help, we help you with the integration, with the support, and the adaptation. So we integrate the software into your products. We have a second level support because we're only a P2P company, and help you with the adaptation of the iOS apps and the web interface. Just more the packages, but yeah, we also do a hardware development. We have some questions about guhIO, about the IF node.
Maybe a question: did you guys try to use the native Android or iOS, or did you
Once again,
native Android or iOS application? Like, do you think it's a good way or bad way to use native apps like native iOS and Android instead of Ionic frameworks for doing the guhIO or app controls, stuff like that?
yeah, we decided to use the Ionic framework because we already have developed the web interface, and most of the software is written for the web interface in AngularJS, and so we could reuse the web interface for the mobile apps.
Okay, that makes sense, but I know we got a bad experience with those frameworks, so
Yeah.
just
it takes more time, but once you deploy it, you have it at all platforms.
Yeah, sure. All right. Cool.
Yeah, it's true. If you only want to focus on one specific platform, for example iOS, then it's of course easier to use the native framework.
Yeah, but we got the issues because with the Ionic, you don't have the access to direct some sensors or the data in the iPhone or in the Android. So yeah, this shouldn't.
Yeah, but we had also some troubles with the Ionic framework because we needed a UPnP support to discover the devices into the framework, and the framework don't support the UPnP, and AngularJS also. Yeah. So we had to make our own plugin for the framework.
Yeah, and the communication is like, do you have any API or anything like connecting to the web management or something like that? Or API, or how are you communicating with the Ionic framework? Do you have any API or anything like that?
At the beginning, we have 3 APIs. A JSON API, mainly used for the command line interface, and the apps on the web interface using the REST API and together with WebSockets.
Yeah, and for WebSockets, do you have any custom protocols, or how are you communicating through WebSockets?
Yeah, we have our own API, but it's well documented and online accessible.
Okay, cool.
Yeah.
Awesome.
Why the command line interface is using another API, another interface? Why not the same?
I'm not a software developer, but I guess it was for him the easiest way.
Okay.
Thanks.
Yeah. The JSON RPC is also very easy to use for external applications. For example, if you need for your specific application and additional wrapper, then you can use the JSON RPC. Yeah. I can also show you later how the software stack works. For example, here's the web interface running. I have the guhIO running on a Raspberry Pi that is working as an edge router. On the edge router is a Contiki running. It's an RPL router. I guess the whole bug. Yeah. For example, this is one of the 6 low-pan modules. Oh, damn it! Okay. Yeah. Yeah. I can show you later if you want.
Okay, cool.
And there's some more questions. Cool. Yeah, some more example implementations. We have now a customer, so an energy supplier, where we have implemented the guhIO for a smart grid connection. So the energy supplier offers an API where you can download the current energy prices, and guhIO decides when to switch on the heat pump, for example, or the pool pumps, based on the current energy prices. Another example is the smart home, of course. Where I have also the Philips Hue here. There are already about 20 plugins available for different devices.
So you were talking about the rule engine. Can you tell me something more about how that's implemented? How do you define rules and how do you trigger the rules?
The rule engine is into the core software. It's written in Qt, C++. The rules you can define various tools. More if a state is changed, if a value is raising above a level or below a level, or
It's just a simple rule engine in terms of
If then.
simple if then, or does
no,
it
it's
have
more or less more than if this and then. You can also add timers or counters or alarms, but really good for time. You can trigger it by any value.
Can you search for patterns? Like if something repeats every 24 hours, or can you search for anomalies, or can you correlate the data
No,
somehow?
that's not possible.
Okay.
Do you have some user interface for giving the rules into the machine, or
The rule maintenance.
It's only possible with the command line interface. I guess at the beginning next year it will be available also at the web interface and the mobile apps.
The rules are defined on edge router or in the cloud?
They are defined in the edge router.
Okay.
So all the software is running locally on the edge router. The cloud server is only used for remote control and for the helpdesk access.
Okay, so if in case I have 2 edge routers and I would like, for example, if temperature on one edge router is exceeding certain value, then please on the second router turn on the heat pump. It's possible or not?
Not at the moment, because we need the kind of multi-cool. You can with the wiring context broker, you can connect the two edge routers, but the two edge routers have not the possibility yet to define a master and a slave.
Okay.
I guess it will be mid 2016 implemented.
In case I would like to implement some new rules, I have to connect to each single router separately. I have no possibility to, let's say, have one centralized point where I will put, okay, I need these rules, and then just deploy, and the rules will be deployed to the routers where applicable. Okay, so separately.
You mean that on every edge router is the same software running in the same setup?
I would like to, for example, change certain, let's say, situation or conditions, and I need, for example, to change 3 rules in 3 different routers. Not the same, but perhaps it's something related. So I have to connect to each edge router separately and to update the rules in edge router separately. So there is no center point where I have all the rules listed, and I say, okay, this is the rule number 15, and this is applicable for the edge router number 5. So there is no centralized.
For this use case, you can use the wiring context broker, where you can define every time you define this entity, it should be deployed on every edge router.
Okay. And next question regarding security. So you have the PEP proxy, so you have the security, and the security is actually from the cloud to the edge, or is it end-to-end from the cloud to the node?
Normal at the moment, the user is setting up the edge router, making his admin setup, and then he connects to the cloud via the interface. So he creates an account on the server. Addition, so he creates first the account on the edge router, and then on the server.
So if I have the communication from the edge router to the sensor, is it somehow secured or not?
At the moment, it's just the security of the 6LoWPAN.
I see.
Standard.
Okay.
The DTL, how's the security level called? DTL? For co-op? Yeah, it will be also implemented next year, but not at the moment.
There is no encryption between devices and the edge router.
No encryption between the sensor nodes and the edge router. Between the server and the edge router, it's
Okay.
Also the communication between the interface and the edge.
But I think in 6LoWPAN you can have SSL, so at least something.
Yeah.
Okay, so thank you, and I would like to see some demonstration.
Maybe I'll ask another couple of questions. So with the example of the bar, the smart light and the button and stuff like that, do you have your own hardware for it, or is that no? So it's just what you.
Mostly the companies with their hardware come to us, and we help them to implement the software.
Okay. And they usually build it on the Contiki framework.
Yeah. We want to switch to the thread protocol if it is available for us. But yeah, it's more or less the same like thread is.
So how do you know how do they set up the devices, like the sensors and the nodes? Because if they're using 2.4 gig network, there's not Wi-Fi, is it? Is it Wi-Fi?
No, it's not Wi-Fi.
It's not Wi-Fi.
No.
So how do you set the network up?
Yeah. Currently, we have the because it's not widely used. It's every time one of our nodes is near the edge router, it automatically appears in it automatically connects.
Okay. Yeah.
But yeah, as soon as we're using the thread protocol, it's a push to connect notification.
Do you know how long the battery lasts?
Depends on the application, but around 2 years.
1 to 2 years.
Does it send some data about the battery level? Or
normally this would display the current battery level, but yeah, the cable is broken. So I can't show it to you now.
okay, but it can send that.
There's also the possibility to how's it called? A kind of WebSocket. Is possible. to generate notifications automatically. No, it's not working.
Okay.
Bad luck today.
Can you show us something from your magic case?
Yeah. Maybe after the